Okay, continuing on with our chapter 5 jeopardy problems, we're going to do the review of logarithms category. So review of logarithms 100, so simplify the expressions. Part A is log base 3 of 3 to the 11th. And so you should know right away that that is just 11. So that's using that inverse property of logarithms. So log base 3 of 3 actually cancel each other out. The 11 goes to the front, and at log base 3 of 3, like I said, it's 1. Same thing here. This one's a little bit harder to see, but it's 7. Now, if you thought about it, equals x. If you switch from this exponential form to log form, it'd be log base 5 of the log base 5 of 7 equals x. So remember how I showed you 5 raised to the other side equals x? That's switching from log to exponential and exponential to log. That's where that's coming from. So now you can see if log base 5 of x equals log base 5 of 7, then 7 is equal to x. So that's why that works. The easiest thing to remember, though, is if you see 5 raised to log base 5 to cancel, it's just a 7. Same thing with the log base 3 of 3. They cancel, it's just 11. All right, this is the property where I have 2 separate logarithms with addition between them. So it's going to be log base 10 of 25 times 4, the multiplication property, which is log base 10 of 100. So 10 to some power equals 100. So that power is 2. So your answer is 2. This one I have 2 separate logarithms separated by subtraction. So it's going to be log base 6 of 360 divided by 10. So the division property, which is log base 6 of 36. So 6 to some power equals 36. So that is 2. Okay, the 200 problem says review logarithms, evaluate the following using a calculator and then change the base. Right, so if I have log base 4 of 6, you can change it to any base you want. So usually the easiest base is log base 10. You can use a calculator or natural log. So it'd be log base 10 of 6 all over log base 10 of 4. So then there's no bases for the 10. So it's one of your calculator. So I would just do this all together. So log of 6 divided by log of 4 on the calculator. We're going to round it 3 decimals, so it's going to be 1.292. Same thing for the next one. It's log of 17 all over log of 9. I always think that taller one or the bigger one goes on top, the smaller one goes on the bottom. All right, so log of 17 divided by log of 9, you get 1.289. Okay, the next one says a log table says that log base 2, or sorry, log of 2 equals 0.301 of 300 and log of 9 equals, etc. Describe how to find log of 18 and log base 2 of 9. Right, I didn't do this with you guys. I didn't have you use log tables, but a lot of times I'll have you guys use log tables. Before we actually had calculators, this is how you calculated logs. It wasn't very fun, but it did the job. So if I have log of 18, and I know I'm going to use log of 2 and log of 9 somehow. Well, 18 is 2 times 9. And I know if I have multiplication, I can separate into 2 separate logs. That's just an addition now. So I add those numbers. So your answer is 1.2552725. All right, for log base 2 of 9, that one's a little bit harder. Log of 9 is 0.9542425. I'm dividing by log of 2, so 0.3010300. And I won't make you do that back in the day, but back in the day they had to. So 0.954 2425 divided by 0.3010300. So I get 3.169924.924. Okay. And the next one is to solve the exponential equations around the 3 decimal places. All right, the first couple are pretty easy. You're just going to switch so that they're the exact same base. So you see how the first one was 10 and the second one was 100. So I'm just going to write it 10 to the 9 minus x equals 10 squared. That's what 100 was, to the x plus 2. This is 10 to the 9 minus x equals 10 to the, you can multiply, so it's going to be 2x plus 4. Well, 10 to something equals 10 to something, so that means those somethings are the same thing. It's like taking log base 10 on both sides. Add the x, you get 3x. Subtract the 4, you get 5. So your answer is x equals 5 over 3. Same thing for the second one. This is base 4, this is base 8, so I can make them both base 2. So it's 2 squared to the 3x minus 4 equals 2 cubed to the x minus 1. And skip a couple steps. I'm going to multiply my powers. So I get 6x minus 8. And on the other side, I get 3x minus 3. So it's 2 to 1 power equals 2 to the other power. Those two powers have to be equal. I subtract the 3x over, so I get 3x. Add the 8 over, get 5. So this one's also actually 5/3. Now you can't get the same bases on these ones. 10 isn't 5 squared or anything. So when this happens, you can just take log base anything on both sides. So I usually use natural log. It doesn't even matter. It could be log base 5 if you want, anything. Right, now you can pull the 3x minus 1 to the front. So I get 3x minus 1 times natural log of 5 equals natural log of 10. Now I can divide by the natural log of 5 on both sides. Okay, I'm going to add the 1 and divide by 3. So I'm going to have whatever natural log of 10 over the natural log of 5 is, plus 1, and then I'm going to divide everything by 3. Okay, so I'm going to do that all in my calculator at once. So we'll do natural log of 10 divided by natural log of 5 plus 1 divided by 3. And that ensures that I don't have a rounding error. So I get 0.810. So 3 decimal places. Okay, a lot of people think when you start that problem out, you have to use log base 5 because you see you have 5 to the 3x minus 1 equals 10. So if you use log base 5, then log base 5 and a 5 cancel. So you just get 3x minus 1 equals log base 5 of 10. But then when you put it in your calculator, you have to switch to bases. You have to switch your bases anyway. So it's going to be natural log of 10 over the natural log of 5, or log base 10 of 5 over the natural log, or log base 10. Gotta say it right. Log base 10 of 10 all over log base 10 of 5. Either way, you're getting the same thing. That's what you have right here. That's exactly the same thing. All right, so the next one, let's just do natural log of both sides. We're going to pull the powers to the front. We're going to natural log of 5, then x minus 1 out front equals natural log of 3 with an x plus 1 out front. Okay, these are the ones that get a little messy when they have the two separate bases. You can distribute your natural log of 5, or you can divide the natural log of 5 or the natural log of 3 over. It doesn't matter. So let's say I have, I have x minus 1 equals x plus 1 times the natural log of 3 over the natural log of 5. So I'll turn this one number. Okay. When I divide natural log of 3 by natural log of 5, I get 0.682606, etc. I'm going to save that as A just in case. And you never know when you might need it again. store alpha A. And I'm going to distribute it in. So I get this 0.68. I'll round for now, but I'm not really rounding it in my calculator. I'm going to subtract my 0.68, etc. x over. So I have 1 minus that answer. So that's 0.31739x equals, and I'm going to add the 1 to that a value. So I'm going to have 1 plus a. And then I'm going to divide by that 0.317 number, which you could also have stored as a number. Okay, so when I do that, I get, so that was 1.68. So you get x equals 5.301. Let's see, your four answers were 5/3, 5/3, 0.810, and 5.301. Okay. The next one, solve the following logarithmic equations, round to 3 decimal places if necessary. All right, so this is log base 5 equals log base 5 at some point. So these somethings have to be the same thing. So if x plus 4 equals 2x minus 8, we like those ones. Subtract your x over, add 8 over, and get x equals 12. This one we have two separate logarithms separated with subtraction. That means I can combine them with division. So it's log base 5 of 25 equals x. So 5 to the x equals 25. So 5 to the second power is what makes 25. So x equals 2. Okay, this one switched to exponential form. I have 6 raised to the other side equals 2x minus 1. So 6 squared equals 2x minus 1. That means 36 equals 2x minus 1. Add a 1, divide by 2, you get 37 over 2 equals x. And the last one, this natural log, is really log base e. So I like to rewrite, because I like to use that trick that I would say. So e raised to the other side equals 2x minus 6. So it's e cubed equals 2x minus 6. So it's going to be e cubed plus 6. All of that divided by 2 equals x. You could leave your answer like that, and if it was like a multiple choice type question, that would be the answer probably. Or you can kind of round with 3 decimal places, so it's better to do that. So that would be x equals 13.043. Okay, so your answers are 12, 2, 37 over 2, and 13.043.